Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. And first, I would like to apologize because this afternoon I still cannot attend the class because I have meeting in the faculty for training of the uh, ebook usage software from the UPT UNES. So hopefully this video can replace my explanation for today's class. And we are going to discuss about the mechanism of process transport and the law of conservation. So basically we are just going to break down the conservation law and also the process transport mechanism, which are containing the mass transport, energy transport, momentum transport. So the process phenomena uses the law of conservation and the velocity equation to find the mathematical model to describe a transport process. So every problems that you are going to face or that you are going to solve, it will need at least velocity equation and also the law of conservation to be solved. So it is the two minimum needed equation that can describe the transport process, that can describe what will happen inside the process, that can describe the concentration, the mass, and also the temperature for each process. So the conservation of flow is the conservation of mass, conservation of energy, and the conservation of momentum. So we are going to focus on these three conservation law. And then, like what you already know from the thermodynamic class, mass, energy, and momentum cannot be destroyed, but it only can be changed the form. Yeah. And these are the mostly processes on the transport. First is the momentum transport process, mass transport process, energy transport process, and chemical reaction processes. And even we are having for transport processes, but in this topic we are going only to discuss the momentum, mass, and energy, since the chemical reaction is already learned in the reactor class or in the chemical engineering reaction class. So the process transport mechanism, there are three mechanisms that can force transportation of the fluid. First, it's due to the molecular mechanism. Second one is due to the convection, and the third one is the turbulent mechanism. The molecular mechanism, it occurs because the force of the attraction between molecules, and all of the phases can be included for the mechanism, such as solid, liquid, and gas. Here are the example of the molecular mechanism in the transport process. We will discuss three different transport process. First is the heat transfer. You can see in here there is a rod and one side is heated by using a fire and the other side is free. So the molecule of the rod at the hot side is become more lighter compared to the molecule at this free side. So based on the difference density or difference mass of the molecule, it will transfer the heat from this side to this side. Yeah. The heat conduction from high to low temperature. So this one is the high temperature, and this one, of course, it will has the lower temperature. And one end burn, one end held, what will happen? The molecules in the heated rod have a higher kinetic energy, and when the molecules collide with each other, energy is transferred from the hot molecules to the cold molecules, and the temperature difference between the fire and the hand is driving force for the heat transfer process. So it just can be easily explained on how the heat is transferred from this side to the other side, because at this side the temperature is higher, so the molecules, it will be moved rapidly and it will goes to the lower temperature side. So the temperature will varies from this side to this side, from high to low. This is what we call as the conduction. And the second one, in the mass transfer or the mass transport, for the example is, in here we have two tubes which consist of nitrogen and also the carbon dioxide. At the initial condition, the pressure and the temperature are equal, and as you can see in here, there is a valve between those two. Yeah, in here we have a valve. So what will happen when the valve is open? So gas has a diffusivity from between one gas to the other gas. So of course this one is nitrogen and CO2. Oh, this one is nitrogen. Nitrogen and CO2. This one is not the oxygen but CO2. Yeah, this one is the CO2. We have nitrogen and the CO2. So this one is CO2 will diffuse to the nitrogen tube, and nitrogen will diffuse to the CO2 tube until the concentration of the nitrogen and CO2 is 50% and 50%, because both of the gases have the diffusivity for each other. So if you find out the diffusivity of the nitrogen inside the CO2, you will get some value, and also you can get the value of the diffusivity of CO2 to the nitrogen. So it will reach the equilibrium at a certain point, no matter how long it will take, but it will move from the higher concentration to the lower concentration. Like in this case, in the nitrogen tube, of course it will has the highest concentration of nitrogen, and at this side it will has the highest concentration of the CO2. So when the valve is open, the nitrogen concentration will be moved to the place with the zero concentration of nitrogen. That is why there is a transportation from this tube to the other tube for the nitrogen. And the CO2 and vice versa for the size for the CO2. CO2 will transport it from this side to the other side. Next, in here we have an example of a tube which is filled with the water and also the calcium permanganate, KMnO4. So at first in here, as you can see, we have a tube filled with the water, and then we have the calcium permanganate crystal, KMnO4 is in the English is potassium, ya, potassium permanganate. Indonesia is kalium. What will happen if we have a tube with the potassium permanganate? The water will change its color from the clear into pink color, because the potassium permanganate molecules move from the bottom of the tube to all parts of the tube. So it will fill all the water. The molecule of the potassium permanganate will diffuse to all of the water inside the tube. So what are the driving force? The driving force is of course the concentration. Why it can be happen? Because the concentration of the potassium permanganate in here is very high, and the water around the crystal has no potassium permanganate. That's why the concentration of potassium permanganate is zero in the water. So it will diffuse in the water, and it will make the water, it will change the water of the color from clear water into the pink color. That is what happens when you are having a mass transfer between the solid in the water. Same condition like when you are making Nutrisari, you are making Milo. That is what happened. Yeah, it has mass transfer process. Next one. Now, this one is the most difficult one to be described for the transport processes. Like the heat transport, you already knew on how it can be analyzed, and also the mass transfer, it can be clearly seen by our eye when there is a difference in the concentration. Then of course there will be a transport process in there. Yeah. But how about the momentum transport? The easiest one on how to describe the momentum transport is by using an example of the water flow or the fluid flow inside the pipe. Yeah, that is the easiest one on how to describe the flow of the water inside the laminar pipe. For example, when you have a laminar pipe, the flow profile at the steady state will be look like this. This one is the pipe, and this one is the fluid profile inside the pipe when it has a laminar flow. Laminar flow is happen when the Reynolds number is less than 2100. Okay, and in here the momentum transport is happen because there is a difference of the velocity between at the center of the fluid and also at the side of the pipe or to the pipe wall. So this difference of the velocity causes the momentum inside the pipe wall or inside this fluid. Like when we are discussing about the heat transport, why there is heat transport, it was happen because there is a difference in the temperature. What about the mass transport? Mass transport occur because there is a difference in the concentration. So what is happening in the momentum transport? It is happen because there is a difference at the velocity of the fluid inside the pipe. That how come there is a difference in the of the velocity inside the fluid? Yeah, if you can calculate the velocity of the fluid inside the pipe by using any measurement like what you already know in the fluid transport processes. There is some equipment called venturimeter or device and pitot tube. It can measure the velocity of the fluid inside the pipe at every point. So you can use pitot tube, and by using that equipment, then you can find out the velocity distribution or the velocity profile inside the pipe when there is a laminar flow or there is a turbulent flow. So if we have a pipe like this, and then for the example in here, yeah, for the example in here, there is a fluid inside two wall, between two wall. This one is the bottom wall and this side is the upper wall. So inside in here is there is a fluid. So, and you have to remember that there you have to declare the coordinates of your drawing, which one is the y-axis and which one is the x-axis. This one it should be x and this one is y, yeah? X and y. So in this figure, as you can see, the top wall is dragged to the right side with a certain velocity, Vx, let's say. So what will happen? The fluid which connect with the upper wall, of course, it will has the same velocity with the movement of the wall, while the fluid which contacted with the bottom wall, it will have the velocity of 0. Based on this information, the fluid inside between this wall have a momentum on the y-axis from the for the y-axis. So the momentum is at the y direction. It's because of the velocity to the direction of x. Because we have a different velocity between at this point and also the velocity at this point. Transfer of momentum in the fluid flow in a laminar manner in a pipe. The transfer of momentum from the pipe axis Vmax to the wall has V equal to 0. So driving force is the difference of the velocity. First one, we already talked about the molecular mechanism. Yeah, we already learned the molecular. And then the second one, there is a convective mechanism. What is the difference between the molecular mechanism and the convective mechanism? So the convective mechanism, it occurs because the property in here means that the momentum and also mass, it was carried out by the moving fluid. So the transport mechanism, the transport process is not caused by the molecule transport, but it also it was happen because there is a convection. Convection means that the fluid movement. There is a fluid movement inside the process. With convection, momentum, heat, and mass, it will move quicker. Yeah, move more quickly. Yeah. So, is it good when there is a convective mechanism? Yeah, it will be better for the transport processes because it will need a shorter time to transport the temperature, the mass, and also the concentration or the velocity faster compared to only use or only based on the molecular mechanism. So this is the example on the mass transfer mechanism by the convective mechanism. So do you still I think you still remember with the sodium permanganate crystal, what will happen if the mixing was done in the process? Of course, the color of the water will turn into pink quicker or more quickly. It was because the movement of the sodium permanganate molecules is not only due to the diffusion process but also because there is convection carried by the moving water. So when you mix the sodium permanganate by using a stirrer, or maybe you are going to stir it manually, it will make the molecule of the sodium permanganate move faster or move quicker than only just you just let it be moved by the molecular diffusion. Like when you are making a tea, when you put the tea bag inside the glass with water, it will equally mix longer when you are just putting that tea bag without any stirrer. But when you stir it, it will become more. It will become apa namanya? Homogeneous. It will become homogeneous rapidly or in a short time. For the convection, there are two types of the convection. First one is the forced convection, and the second one is the free convection. Forced convection because there is a power from the outside to do the convection process, and free, there is a difference in the density due to the difference in the temperature. So force, of course, it was happen because you force it, you make that happen. While the free convection, it was happen naturally. It's due to the difference of the density, difference of the temperature. This one, heat transfer. Heat loss in the car radiator, air circulated by the fan. Is it free or forced? Of course, it was forced because there is a fan which make the heat is distributed equally inside the radiator so that the temperature is not too high. Cooling coffee by blowing, of course this one is also forced because you force it to cool down by using an air blow by using fan or by using your own mouth. And then third one, heats water in a pot. Heats water in a pot. If the pot is heated by using fire, then it is just only free convection process. The third one, so the first one is the molecular, second one is the convection, and the third one is the turbulent mechanism. The principle is the same as the convection mechanism. Like on the mass transfer, the water contains sodium permanganate crystal. When you stir vigorously so that there is an eddy turbulent flow. So the turbulent mechanism means that you are causing or you are using more power or more velocity on creating more flows inside your fluid. Like the example in here, you are stir the sodium permanganate rapidly or vigorously so that there is an eddy current. Eddy current, like there is a swirl inside your tube like this one. So it will create a vortex. Then this one's, we can say that this process causes very or highly turbulent. Means that the Reynolds number or is, of course the Reynolds number in here is different because this one is the mixing Reynolds number. Mixing Reynolds number is different with the Reynolds number on the pipe. Yeah, the equation is also a little bit different. You can find out the equation in the textbook. So this one is the when the fluid flow stir and created a vortex, means that the flow inside the mixer or inside this tube is very, very turbulent. That's why there is not only convection, but there is also the turbulent mechanism. So the diffusion becomes much faster when there is a diffusion, molecular diffusion when there is a convection, and also the turbulence of the fluid. So this is the general rate law of the velocity equation. Rate is the driving force divided by the resistance. Rate in here, it can be rate of the mass transport, the heat transport, and also the momentum transport. If the driving force is large, then the rate will increase, and if the resistance is large, the rate will decrease, yeah, as it can be seen in here. When you have a very high driving force, then the rate also will be higher, and when the resistance is high, then it will decrease the rate. Like when you have a difference on the temperature, like the driving force in the heat transfer, means that the heat transfer rate will be much higher compared to when you are having low driving force or low temperature difference between two sides. In here, for the heat transfer, the rate is Q, the resistance is dx over Ka, and the driving force is the difference of the temperature. So the equation based on this one, rate is driving force divided by the resistance. Rate is Q, driving force is delta T, and the resistance is delta X over Ka. When you recreate the equation, it will form the Fourier law. When Q over A is equal to minus K dt over dx. And this one, what we call the flux, heat flux. When you have the rate of heat transfer divided by the surface area, this is what we call as the heat flux. Same equation is as you can see in the mass transfer. The resistance is dx over dA. In here, the K is the conductivity, and when this one, T is the diffusivity. In the mass transfer, this one is not dx yet, it should be dc. dc, oh sorry, dx, dx, it's through dx. dx over diffusivity times A, the driving force is the difference of the concentration. I thought, let me clear it. Okay. dx over dA times A. So when you recreate the equation, it will looks like this. JA is equal to minus dCA over dx over dA times A, and then the flux, mass flux, is minus diffusivity dCA over dx. So this is what we know as the Fick's law. Yeah, this one is the Fick's law for the mass transfer. And for the momentum transfer, so this one, momentum, like from the previous figure, we have a difference on the velocity. Like this one is the direction of the x, and this one is the direction of y. So this one is called as the momentum to the direction of y due to the velocity of x. Yeah, the velocity distribution is at the x direction, so it will has the momentum to the direction of y. This one is the momentum. So the resistance is dy over mu, and the driving force is the difference of the velocity. So by using rate is equal to driving force divided by the resistance, the momentum of yx is equal to minus the difference of the vx divided by dy over mu. And this one is what we know as the Newton law of viscosity. So this one is the general equation that can be summarized from those all three transport processes from the heat transfer, mass transfer, and also the momentum transfer. So this one is the flux, yeah. This one is the flux of the heat flux, mass flux, and also the momentum. So this one is the flux, and then the difference is the comparative constant, or also known as the diffusivity, and this one is the variable gradient of the property. In a table, it will be look like this. The flux for the heat is Q over A, mass is JA over A, and the momentum itself, it is already the flux. The diffusivity is K over rho Cp, which is conductivity, density, and also the heat capacity. And then for the mass transfer, the diffusivity is the diffusivity itself also. And in the momentum transport, the diffusivity is mu over rho, or it is also known as the kinematic viscosity. So for the gradient, there is delta P, dP Cpt over dx, and then for the mass is dCA over dx, and the momentum is d rho Vy over dx. So if we have law of the conservation, which is the property accumulation is equal to the mass property input, mass minus mass property output, and also the mass of the property generation. So if you have the flux entering a certain volume at the one point and exit at the point 2, you will get the equation of this one for the unsteady state equation. So dt dv over dt, so this one is the unsteady state. The input is a cx 0.1, the output is a cx 0.2, and then plus C generated times delta V. So this one is actually the basic of the mass balance. Yeah, mass balance. So by using all the processes, and then you can follow just slowly. First, you divide all the equation by using delta V, and then you assume that the delta V is almost to 0, and replace the value of the Cx, C and M. There is M and C. M and C in here is the molecular and also the convective. Yeah, the molecular and also the convective. So the flux movement at the direction of, so this equation basically just happen only one direction, which is direction of x, yeah, because in here you only use x direction. So the x direction itself, there is molecular and also the convective one, and the mcg is the generation. So by deriving, by simplifying the equation, you will get the final value of the equation of the unsteady state, this one. Yeah. So actually we are not going to use, this one is the one-dimensional, yeah. This one is the one-dimensional general equation for the property conservation, and this one is for the three-dimensional. So as you can see, in here you still have the x direction, and x direction, while in here you find that the direction is gone and it was changed by using a tensor. So this one, it will has the same equation at the direction of x, y, and z for the cubical coordinate, and radius, height, and also the theta for the cylinder, and also there will be another coordinate for the ball coordinate. So for this for today's class, I would like to just introduce you on the equation of the law of conservation and also the transport mechanism of the mass transport, heat transport, and also the momentum transport. That's all. Next week we are going to find out, or we are going to discuss each example of the momentum transport, heat transport, and also the mass transport, heat transport, and the momentum transport.